We are starting our section, or chapter I should say, on rational exponents. So think about what that means, what a rational exponent would mean. Rational numbers, you remember, are numbers that can be written as fractions or quotients. So that's just an exponent now, that's a fraction. So chapter 6 is on rational exponents and radical functions. And so think about what a radical means. That's when you're taking a root of something and what that function would look like. It's a whole other function family. But before we can get all to that, we need to start with the basics like we usually do. And what this section, 6.1, has to deal with is the idea of the square root, where you had a number such as the square root of 16, and you know that that is plus or minus 4. Again, the square root is a factor that times itself gets you that number underneath the radical, the 16. So we'd get plus or minus 4. But that was two factors that got you 16. Now we're going to move it on to other roots, not square roots, but maybe cube roots and fourth roots and other roots beyond that. So in general, we're going to say for an integer n, so that's just basically a whole number with negatives greater than 1, if you have some number to the nth power and it equals a, the b is an nth root of a. So let's write that down and think about it, what it means. The b is an nth root of a. So whatever number multiplied to the power of n gets you a, then we call it an nth root. An nth root can be written as this funny symbol here. So we're used to the square root symbol with a letter, we're going to use a underneath it. But now instead of just leaving the radical, we need to put a little number there to indicate it's not a square root, but maybe a cube root or a fourth root. Okay, so an nth root can be written as I just wrote there, where n is the index of the radical. So that's just a vocabulary word you'll hear from time to time. That is the index of the radical. So let's look more at what we're talking about here. We have square roots of 16 was plus or minus 4. And so if I asked you, and we dived into this a little bit, if I asked you what the cube root of 8 was, what I'm really asking is what number times itself 3 times gets you 8. And so the cube root of 8 would be 2. If I asked you what the fourth root of 16 was, what I'm really asking you is what number times itself 4 times, that's the fourth root, would give you 16. Well, that answer is 2. And the reason is for these is because 2 times 2 times 2 times 2 equals that 16. So we're just looking for more factors that are identical that give you a product. So using this notation now that we just went through, the nth root notation, if I asked you what the cube root of 8 was, now we would write that differently. And I would write it as, put an a underneath, and now I'm asking for the cube root, so you put a 3 there as your index, and this is how we communicate with you that we're looking for the cube root of 8. And so we would say that equals 2, and the fourth root of 16 is 2. Alright, so there's another little side note we need to go through about square roots and writing them and cube roots and fourth roots. And that is this property. A while back when you had a number and you square rooted it, we would always undo that by squaring it. Do you remember? And those canceled each other and you would be left with the number a. Well, that's to the first power if you wanted to be particular. The same also holds true if I had a cube root of some number a. I would undo that as well by cubing it. So another property comes out of this, and that is your rational exponent idea. And instead of writing the square root or the cube root using the radical symbol, we can also write them using fractions. So I'm going to rewrite this one as a, and instead of a square root, I'm going to write 1/2. A to the power of 1/2 is actually a square root. And so then if I squared it and used the power of a power property, that one tells you to multiply it, right? So 1/2 times 2 gives you that a to the first power. Let's do that same thing so you can understand what I'm saying with the cube root. instead of writing it with radical notation, and we'll talk about this a little bit more, but instead of writing it as radical notation with the cube root and a radical with the index of 3, we can write it as a fraction of 1/3. So 1/3 means a cube root. And then just to prove it's true, if I took the third of the power of 3 of a cube root, it undoes it because of the power of the power property, and you end up with 1/3 times 3, and that's 8 to the first power again. So you just need to understand that there's two types of notations for these roots. There's the radical notation, and then there is the rational exponent notation. So anytime you have a fraction with a number in the denominator, that number in the denominator is the root that you're looking for. Here's the square root, there's the cube root. It would work the same for the fourth root and any root. So let's look at what this key concept is saying here in this box right here. It's kind of important, and it helps you when you're deciding the signs of your roots. With your square roots, you know, you always had your positive and your negative root, but it's different when you have negative integers underneath a root, because you might have some imaginary numbers here, and we know how to deal with those now. So let's look at this key concept really quickly. It says if your n is an even integer, or I should say your index is an even number, like a 2 or a 4, and the number underneath the radical is negative, you won't have any real nth roots because you're going to have imaginary roots, but that's okay. So you'll have imaginary numbers pop up in here sometimes. We're not going to deal with that at all because it just complicates things. It doesn't really mean anything. And then down here, when n is an even integer and your number is greater than 0, you have two real roots, the positive and the negative root. And that's just what we got up here. This is like this example up top. So that's really nothing new there. Now let's look at if n is an odd integer. So if n is an odd integer and your value underneath the radical is negative, you will have one real root. And an example of that would be, let me write this, if we had the cube root of a -1. Well, remember what the question's asking. What number times itself 3 times would get you a -1? And that answer is only a -1. A positive 1 wouldn't do that for you. So this is an example of your value under the radical being less than 0 or negative, and that you're going to have one real root, and in this case it's -1. Again, if a is 0 underneath the radical, your answer is 0. So we'll just cross that out because sometimes too much information can confuse us. And then finally, we have what happens when you have a number under the radical and you have an odd index. You're going to end up with one real root. It's either going to be positive or it's going to be negative, and it just depends on what a is. So let's work with some examples of these. We will shift down here and look at actually finding some nth roots. So our first directions tell us to find the indicated nth root of a. So here our index is 5 and our value of a is a -32. So that's our base number. We could write this two ways, so we'll just practice writing it the two ways. So we're looking for the 5th root, so 5 is my index and -32 is my number underneath. You are very welcome to write this also in exponential notation. Oops, and that's not a 1/2, it's a 1/5 because I'm looking for a 5th root. So the question is, in both cases, and it's just written two different notations, is what number times itself 5 times will give you a -32? And that answer, after you think about it for a while, is a -2 for both of them, depending on how you write it. B then gives us an index of 6 and a base number of 1, and so they're asking us, what is the 6th root of 1, which you can write with radical notation, or if you wanted to write it as exponential notation, it'd be 1/6, or 1 to the power of 1/6. So what number times itself 6 times gives you a +1? And this answer, because it's an even index, is plus or minus 1. Don't forget about those positive and negative roots. Here you only had one option for an answer, and that was the -2. All right. This key concept area here goes through some rational exponent properties, And sort of what I just wrote using this exponential notation, but a little more involved in that now we might have a numerator, a number in the numerator. So if you have a base number a to the power of m over n, and that's your exponent, you can write it in two different ways. You can write it as 1 over n to the power of m, and this is using the exponential notation for your root. That 1 over n is just like this 1 over 5 here, and then they're using this numerator outside of the parenthesis because of the power of a power property. You would get the same answer by multiplying 1 over n times m. You would get that back out. Otherwise, you could write it as a radical using n, whatever number that is, as your index, all to the power of m. So you need to keep these properties in mind because you need to use them very comfortably very soon. Here you have a negative exponent. It's a rational exponent, but it's negative, and that still means the same thing, where if it's in the numerator, you need to move it to the denominator so it becomes positive. And then again, down here from this step to this step, they're just using this first property again, and that is that you can separate the numerator from the denominator by writing 1 over n, which is really your index, to the power of m. And here they're using radical notation. So stare at those a little bit. And then we're going to do example 2 here, which is using those properties of rational exponents. So they're asking you to evaluate 16 to the power of 3/2. And I'm sure you want to run to your calculator, but you're not going to be allowed to. You have to really inherently understand what these properties are telling you. And so we're going to rewrite letter A using the properties we just learned. So if you have 16 to the 3/2 power, write it separately as 16 to the power of 1/2. That's coming from this denominator, and the idea that that is a square root, the square root of 16. And then we're going to put the numerator on the outside, which is the 3. And then this doesn't become such a hard problem, because recall what it's asking you. It just wants to know the square root of 16. Well, you know what that is. The square root of 16 is just 4. And then the cube comes after it. And then now when we cube 4 to the power of 3, that's just 64. All of that done without a calculator and just using the properties. So let's try it with B. We have 32 to the negative 3/5 power. And so we have a negative exponent, and you know how to get rid of that. You throw the base number into the denominator and make it now a positive exponent. So you have 32 to the power of 3/5. And now break up that rational exponent into its index or root. And so we really have 32, and I'm going to use the denominator of 5. So 32 to the power of 1/5, that's a 5th root of 32. And then after we find that, we're going to cube it. And this was our first example we did for this section. So the 5th root of 32 is actually 2, and we're going to cube that. So we get a final answer of 1/8. Again, you can't use calculators on these. I will be expecting you to show me that you understand the properties of those rational exponents. Before we do example 3 on this page, actually using our calculator, which is fun, I want you to do the guided practice so we don't forget what we just learned. So do 1 through 8 and come back and check your answers. So go ahead and pause the video now. Alright, here are your answers for the guided practice. So you can pause the video and take as much time as you need to correct them. If you have questions, ask a neighbor or find a teacher like me, and feel free to ask. It can get very confusing with the signs of your answers, but you just need to remember that these are just notations for repeated multiplication. So double check your signs by maybe reversing the process in your head and making sure that you get the right signs for your base number. Alright, I'm going to go to example 3. All the kids always love this because we get to use our calculator. And there's 2 types of calculators running around in this classroom. Some of them are TI-84s, and other ones are the TI-30s. So I'm going to go off on the TI-84, how to use your calculators, because most of you should have them. And that is to put in different roots. So when you have 9 to the 1/5 root, and to put that in your calculator, the keystrokes you would do would be 9, and then you're going to hit that caret button, and then I do parentheses, and I do 1 divided by 5. So that is an option to do that. to get your answer, and then that's going to be a decimal. And then if you have 12 to the 3/8 power, you would do the same thing. It would be 12, use the caret button, and do 3 divided by 8 in parentheses, because then you're telling the calculator that that whole thing is your exponent. I'm not quite sure because I don't have them in front of me, but if you have a different calculator, they often have signs that look like that, like a button, and there's maybe a number under here, or maybe not, like or a letter under there, like an A or something. But what that's doing is that is you having the ability to tell the calculator what number X is. And so I believe you would hit like 8, and then you would do, actually let me use 16. So you would use 16, the key stroke would be, you'd hit 16, and then you'd hit that button. And then if we were taking, say, the 4th root of 16, then you would type in the 4 right after it, and then you would get your 2. And then if you look at example C, you'll notice that they're using the radical notation, and in order for you to put this in your calculator, you need to actually convert it into exponential form, and so you need to understand that your 4th root number, the 4 goes in your denominator and the 3 goes up top. So you're going to have to be able to convert that before you put it into your calculator. So let's have you practice with your calculator. You can do guided practice exercises 9 through 12, and notice that they want you to round your decimal to 2 places. So go ahead, pause the video, and do that on your calculator, and let's see if we get the same answers. Alright, and here are your answers for 9 through 12. Hopefully you rounded them correctly. Alright, let's move on to another example. And now we're going to take it another step further and actually solve equations that aren't just square roots, but maybe cube roots and 5th root from what I see. This really isn't a new process. You've done this before with square roots, and so those rules still apply. For example 4a, you have this equation, and as normal when we had square roots, you always needed to isolate the variable, and then at the end we're going to take care of that cube root. So our first step here is to isolate the x cubed, and so we would divide by 6 to begin with, both sides, and we end up with x cubed equals 64. Well, what would we do now? I need to get rid of an x to the power of 3, and to undo that power of 3, we cube root it. But we have to do it to both sides. So I'm going to cube root the left side, and I'm going to cube root the right side. And those two things cancel right here, and that's because of this idea that you have x to the 3rd, and really now I'm cube rooting it, so my 1/3 would be on the outside, and then the power of a power here, 3 times 1/3 is x to the 1st power. So that is the reasoning behind why we're cube rooting something that's cubed. And then your job is just to finish it up. And so you're isolated your x over here, and the cube root of 64 is just a positive 4. And that is that answer. Moving over to letter B, we have trapped inside the parentheses and this quantity our x minus 8 to the power of 5. So we can't do anything until we undo that 5th power. So we undo a 5th power by taking a 5th root, both sides. And then rewriting that we now have x minus 8 freed, and we are left with the 5th root of 100 on the right side. Now what you would do is you can take your 5th root of 100, and you're going to get 2.51. You can also leave that to the end actually, which is maybe what I recommend just for rounding purposes, but that was using your calculator. You get 2.51 or 2 51/100ths, and then add 8 to both sides to get a final answer of 10 51/100ths. Down here we have a problem, word problem, no big deal, we'll just read it. It says a study determined that the weight W in grams of a coral cod near some island in the Philippines can be approximated using this model. So it's not like we have to write it, they give it to us. And they're telling us L is the coral cod's length, and to estimate the length of the coral cod that weighs 200 grams. And so they just told us the weight in the problem, if you notice. They said it weighs 200 grams, so that would replace W in our equation. And then you write down the large decimal, and it's the length cubed. So I need to solve for L cubed because we're estimating that length. Your first job is to isolate L cubed, and so you would divide both sides by 0.0167, and then you end up with 11,976 on the left and L cubed on the right, and your next step is to undo the cube by cube rooting both sides. And then you will end up with L isolated on the right and 22.9 for your answer, and that is in centimeters. So the length of the coral cod that weighed whatever you saw there, grams, would be 22.9 centimeters. All right, here's some guided practice involving what you have just learned. So pause the video and solve all 6 of these. And it's really important that you guys do these because this is the time to make mistakes. So you don't want to do an entire homework problem or homework sheet wrong and find out after you've just stored that all in your memory incorrectly that you've done it wrong. So make sure you get them right before you move on here. Pause the video and come back for the answers. All right, here are your answers for 13 through 18. Go ahead and check them, but pay particular attention to number 18 because this is a situation where you're going to have 2 answers, and that's because the 4th root of 16 has 2 roots. It's either a positive or a negative 2. And so when you have 2 roots like that, and then you finish solving your problem for x, you end up with 2 equations. And so you'll have -3 or -7 ending up being your answer. Both of them would work if you substituted it back in there. And this happens when you have that even power or even index, that you will have 2 roots like that. And this problem is so common, and I have to say so many students make mistakes by ignoring those 2 roots, and they'll only come up with an answer. And so just really pay particular attention to those kind of problems.